All right, this is trig lesson 1.4, and kind of for the first time in the chapter, we're going to get some trigonometry. The first couple sections were review, and now we'll get into some trigonometry. And so we start with the definition of the trig functions, and you might be reading that thinking, wait, this isn't new. We've done trig functions. We did trig functions, sine, cosine, tangent. We did those back in geometry. This isn't going to be new. But it is going to be a little bit different the way they're defined here. We'll relate it back to sine, cosine, and tangent, the SOHCAHTOA. You might remember from geometry. We'll relate it back to that, but it's a little bit different the way they're defined here. So you want to kind of watch this and see how it's different, and then also see how it's the same. You look and say, wait, that is really the geometry, once you make the connection. So here's our rules for measuring angles in trigonometry and beyond trigonometry in any math course. These are the agreements. First of all, we define an angle. It can be any variable, but it seems like the tendency is to use Greek letters. So instead of your standard, your x's or your y or whatever, when we're doing trig, it seems like we switch variables and we choose Greek letters. And so we choose the letter theta a lot of times for a variable. There's nothing special about theta. It could be an a or a z or whatever, but we use theta instead. So our variable, our angle, is going to be theta, and that's going to stand for some angle. We said before we could measure it in degrees or radians. Mostly right now we'll just stick with degrees. Next thing is, when you measure an angle, the agreement is everybody's going to start on the positive x-axis, which is here. So the idea is when anybody, whenever anybody in the world measures an angle or draws an angle, if we all have this same way of doing it, we'll all have an angle that looks the same when we're done. So we're going to start in the positive x-axis. When we go on the positive x-axis, we're going to go counterclockwise. So we're going to open up counterclockwise when we do it. And then the new thing in trig is what we're going to do is we're going to look at where does this end up? So what's the point? What are the coordinates of that point? I'm just going to erase that green line so we can see it better. And so the question is, what are the coordinates of the point where when we open this up counterclockwise, where do we end up? So you start with a line, you open up counterclockwise, and then the question is, where does that point end up? Okay, let's look at this. Let's relate it to geometry, because in geometry you also had sine, cosine, and tangent. And in geometry you use sines, cosines, and tangents to solve triangles. So the easiest thing we can do is sketch in a triangle, and the best way is drop a perpendicular right down here to the x-axis. And so you can kind of see now we've got a triangle. This distance going left and right is our x-coordinate. The distance going up and down is our y-coordinate. And then the hypotenuse is going to be very important. We're going to use this a lot in trigonometry. The hypotenuse of our triangle we get from the Pythagorean theorem, which we did in a previous section. And now you see, oh, it's kind of nice I've got that. So our hypotenuse, which we now call r, kind of like a radius, r equals the square root of x squared plus y squared. Okay, so when you have this triangle here, hopefully you think back to the little bit of trig that you did in geometry, and now we're going to get the definitions of the sine, cosine, and tangent. We're going to define them in terms of the x and the y and the r, but if you remember SOHCAHTOA, opposite, hypotenuse, adjacent, hypotenuse, those kind of things, you're going to find out it's the same thing. Okay, let's look. We're going to kind of flip back and forth here. Let's take a look at our definitions. So our first trig function we're going to define, let me just put a shade here so we're not looking at too much at once. So the first function we want to define, actually let me try that again. Let's do it this way. First function we want to define is our sine. And you might remember from geometry, SOHCAHTOA, which was the sine is the opposite over the hypotenuse. Let's come back and look at our picture. Sine is opposite over hypotenuse. Let's look back at that triangle we've got. Sine is the opposite. Oh, look, that's the y-coordinate. And right here's our hypotenuse. So sine is y over r. Just like the SOHCAHTOA, it's a little more general because nobody says you have to stop in the first quadrant or the second quadrant or the third or the fourth. Whereas triangles, you would never get an angle bigger than 180 in a triangle. Now you'll see as we go through this in trig, we can open this up and that xy coordinate can end up anywhere. So it's slightly more general than geometry. You won't see that today, but we will see that. But it's certainly the same idea. So look at that. Sine is y over r. Looks good. All right. Then for every trig function, there's a reciprocal trig function. And very, very helpful before calculators because they have tables with sine values in it and tables with cosecant values, and it saves you a lot of division. Still somewhat useful. We will kind of focus mostly on sines, cosines, and tangents. Occasionally we'll use a secant or a cosecant or cotangent. But anyway, we have our sine. The reciprocal of sine is cosecant. So sine and cosecant are reciprocals. So the definition makes sense. You take y over r from sine, flip it over, and you get r over y for cosecant. All right, let's keep following these now. See what we've got here. Cosine. Remember cosine from geometry? SOHCAHTOA, cosine. Cosine was the adjacent over the hypotenuse. And take a look back at our picture just to refresh your memory. The adjacent angle, getting maybe too many lines on here, but here's our angle theta. Adjacent to theta, look, that's right there, x. And our hypotenuse doesn't change, that's r. So cosine is defined to be x over r. And the reciprocal of cosine is our secant, so that's the secant right there. And the secant is reciprocal, so since cosine was x over r, we take that, we flip it over, take the reciprocal, and we get r over x. And then our third pair here is the tangent and the cotangent. And so we got to the TOA part, and tangent is opposite over adjacent. Look back at the picture one more time. But the opposite side is y, the adjacent side is x, and we flip that over, and we get our cotangent. Okay, these 6 definitions you will want to commit to memory. There's probably a little more memorization in trig than in any previous math class. It's not a lot, and we'll kind of gradually build into it. But these 6 you will want to know just off the top of your head. And again, if you forget them, think back to geometry, SOHCAHTOA, that will work also. Okay, let's practice using these a little bit. So, just, again, nothing amazing here, but just to practice, do you have these definitions down? They want to know the value of the 6 trig functions, so sine, cosine, tangent, cosecant, secant, cotangent. And they're going to talk about some angle, and all they're going to do is tell you when they drew the angle, here's where it ended. So terminal is where it ended. You might want to sketch this out. Later on you realize you don't really need to sketch these out. You can just kind of see this. But early on, let's sketch this out. Okay, we've got our coordinate system here. Somebody opened up an angle, and they ended up at 512. So I'm just we're gonna call that, I won't mark all the tick marks, call that 512. So they started on the positive x-axis. They rotated counterclockwise, ended up right here at 512. You guys know what to do. Sketch in a right triangle. We know right here is the x-coordinate 5. Right here is the y-coordinate 12. And really, what these are going to be is it's going to be an exercise in the Pythagorean theorem. Look, they gave me x, they gave me y. Can I figure out this r right there? And again, it's the Pythagorean theorem. R is going to be, or let's go r squared equals 5 squared plus 12 squared. R squared equals 25 plus 144. R squared equals 169, and this one works out nicely. The square root of 169 is 13. And you might think, wait, what about plus or minus? We're measuring distances here. R will always be positive. X or Y, you might think about it. X or Y could be in the second, third, or fourth quadrants. They will not always be positive. But R will always take on a positive value. So R is always positive, and not true for X and Y. We could put those in the second, third, or fourth quadrants and make those negative, either one negative or both negative in the third quadrant. So R will always be positive. So we just figured out R equals 13. I'm going to move a little of this out of the way here. So we got r is 13. And now our question is, can we define sine, cosine, tangent, cosecant, secant, cotangent? And the answer is yes. The sine of theta was y over r. So wait a minute. I know what y is. It's right here. I just figured out r. It's right here. So the sine is 12/13. Probably the quickest, easiest one to get next would be the cosecant, because those are reciprocals. So CSC was the reciprocal. It's r over y. So it comes out to be 13/12. All right, we got one pair. Let's go cosine. Cosine of theta is adjacent. I was going SOHCAHTOA, adjacent over hypotenuse. Or here it's x over r. So the cosine is going to be 5/13. The reciprocal of cosine is secant. So the reciprocal will be 13/5. And we need just two more. Let's get the tangent. Y over x, 12/5. Look, we didn't even need r for that one. And the cotangent is the reciprocal, 5/12. So we've listed all 6 of these. And that's what, again, we're just practicing. Do we have a handle on these trig functions? And that's what we're doing in this first section. The book puts them in a funny order, and I'd have to look back now. I don't have it handy with me. But when you're checking your answers in the back of the book, realize it's probably not in the order we listed. I believe they go sine, cosine, tangent. Then they do the reverse. They do the reciprocals, but in reverse, they go cotangent, secant, and cosecant, or something like that. We'll clear that part up in class. But when you're checking your answers, beware of the order that they put those in. Okay, I'm going to pause here. You can try the next problem. You'll notice right away that x already is negative. R will never be negative, but look, the x is negative. And if you want to practice that one on your own, you can. We'll do a couple more of these in the next video just to make sure you've got this down.